thermal stability. So our syllabus talk on nitrate, carbonate, and hydroxide, which are all, if you look at it, polyatomic ions, first of all. Make sense? Okay, now, so we all know that these, or all of them will form your metal oxide. And after that, the byproduct, right, which is here and here and here. Okay, so this equation, each of them 1 mark itself with state symbols. All the best, good luck to you. Good luck to you. We need to be able to explain it, which is, I think, quite easy. I just want to warn everyone something here in case you're not aware. Right? Group 2 compounds I can see here, they become more thermally stable down group 2. Why so? If you look at it, the only difference between them is the cation, right? So Mg2 plus to Ca2 plus and so on and so forth. All right, what is the difference between them? It's about size of the ion. Okay, you so ugly. Right? Okay, let's talk about this cation first, the positive ions. Positive ions, since bonding, so it's a revision of bonding, by the way. We talk about polarizing power or polarizing ability. What is it? It's the ability of the cation to distort the electron cloud of another ion, atom, or molecule. And its cation is all about what? Cation is all about charge density. Right? Whenever you have a cation, we tend to talk about charge density. So the higher the charge density, right, obviously greater the polarizing power of the cation, the ability to pull electron towards itself. And we also learned that group 2 cations are actually very, they tend to say we tend to say they have very high charge density. Right? Why? Because they're pretty small compared to group 1, and they're highly charged. Right? Once again, compared to group 1. So they have very high charge density, the group 2. Right? We consider them to have high charge density. So they will have the ability to polarize the anions large electron cloud very, very well. What they do is they weaken the covalent bond, if any, within the anion. Why got the word if any? Typo, maybe don't need that word. I write too much. Is it? Why need to? Okay, so question mark. Weaken the covalent bonds within the anion. Okay, so later I'm going to come back and look at the question mark. So the compound will decompose on heating as the weakened covalent bonds within the anions are easily broken. Okay, so let's come back here in a short while. Don't worry. Now the polarizing power, all right, decreases down group 2. So this obviously will be heavily tested, and this is the standard answer. It has to do with charge density, as you can see. So let me write out the CD again. As we go down the group, what happened to the CD? The charge density. Okay, so here we go. What do we know? The cationic radius increases, so the size gets bigger. The charge remains the same, so it's the same. So obviously the charge density this time around, what happened to it? It decreases. All right, so once again, this decreases. So there will be less polarization of the anions but the larger cations, i.e. the less ability to distort the electron cloud. And therefore the bond in the anion, carbonate got CO, nitrate got NO, hydroxide OH, covalent bond is less weakened. And therefore ease of decomposition decreases, which also means you need higher temperature, if not longer time. And therefore they are more thermally stable. Okay, all make sense? Standard few words, give it to them, get 2 marks here. So keyword is it every anion can be broken? The answer is no. Why? Here. Now, polarizability. Cation, polarizing power. Anion, polarizability. Everyone okay? Since bonding has always been like that. So the anions here we have been talking about, right? Based on the three equations, is the carbonate, the nitrate, and the hydroxide. Correct? These are the anions that we're looking at. So we talk about polarizability of them. What is polarizability? Formal definition is the ease of which the anion, atom or molecules, electron cloud are distorted by another ion, which is by the cation, right? So by the cation. Okay. Polarizability means pooling. Everyone okay? Pool electron cloud. It doesn't mean it weakens anything. Yeah? Polarizability is all about pooling the electron cloud. How you distort electron cloud. Full stop. Only polyatomic ions, or anions, sorry, are susceptible to the breaking of covalent bonds, of the quick breaking of the bonds. Why? Because carbonate, nitrate, and hydroxide has covalent bond. Hydroxide ion has covalent bond. Nitrate ion has covalent bond. Carbonate ion has covalent bond. For monoatomic elements or anions, the polarizing, all right, only cause the formation of ionic compounds with some covalent character. It doesn't break any bonds. And that's the reason why metal oxide will never get decomposed, usually. I repeat everything with a quick diagram here. Sort this out once and for all. We don't come back here again. So here we go. Now, what is the whole idea about polarizability? It's about this. I have a positive cation, a positive means cation, and I have an anion. All right. So the idea is always this: is that okay? Let me use a different color. Right, the negative ion is here. This is an electron cloud, right? So they get near to it. Okay, I'm positive, you're negative, let me attract you. So they'll tend to like pull them, correct? So we've seen this diagram in chem bonding. Remember, they pull them, right? You saw this before in your notes or my notes, right? It's everywhere. How they tend to pull. That is the job of the cation versus the anion. So what happened right now is if you have a cation here, say, okay, I use calcium now, okay? Calcium carbonate decompose, right? Okay, I use calcium 2 plus. Then what is the anion over here? The anion is the carbonate, let's say. The negative charge, right? It's by right, look like this. Make sense? Okay, like whatever the shape, I look something like this, right? But because of the cation is being pulled, right? It's being pulled. Pull until what? Until it weakens the bond and one of the bond break. And if you look at it, this is how come you get calcium oxide and carbon dioxide. Obviously, there's a reaction mechanism in the middle. Curly arrows. Okay, so you weaken the bond. Now, if you take a look at a calcium oxide, for example, will it polarize it? Be careful, yes, it does pull it, it does polarize it, which is called distortion of electron cloud. But what they only do is there's no covalent bond inside there, so it cannot break. So the only thing it did is to kind of like join it a bit. So that's why this is known as what? Calcium oxide also, all right? It's known as an ionic compound with covalent character, some covalent character. Aluminum obviously more drastic because it pulls more, until it's super duper close to it. That's why we say have a strong covalent character. Covalent character. Am I okay? So once again, every time you got polyatomic anion, decomposition may occur. With group 2 cation, it will occur. Let's assume it. Yes. But if it's a simple ion, an ion that's from the atom of the periodic table, there is no such thing as decomposition. Am I okay? So calcium oxide, you heat anything, no reaction. Whatever, right? Aluminium oxide, you heat any decomposition, no reaction. Because they don't have covalent to break. There's no decomposition. There's no breaking of covalent bonds. Okay, everyone? That's it. Everything about that. So we have nitrate, we have carbonate, we got hydroxide. What about other polyatomic ions? Sulfate, can not? Your school got talk about sulfate? Is it in the notes? Besides sulfate, you got other thing? Phosphate? There's so many, right? So what do? We have for it to come out. Make sense? If we don't know what the product, because it's not in our syllabus, they will tell you what product is being formed. They'll give you some clue and then you pull them out accordingly. And the explanation is always the same. Can everyone? All right, so this page is yours, 3 marks. If you ask me.
If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.